As daylight fades and the crew receive their briefing, an aircraft is about to be wheeled out for takeoff. But on this flight, apart from me, there's another unusual observer. Housed in a pod in the plane's belly is a camera, a piece of electronic gadgetry that can greatly enhance the effectiveness of the aircraft and crew's operation. To the pilot, poor visibility can be inconvenient, time-wasting, and at worst, risky. Even on a clear night, the ground below is just a jumble of lights. So in this context, night flying, even in good conditions, is not without problems for the aircrew.
And what makes a vital contribution to safety on a peacetime flight like this, the ability to see the real world outside, even though it's pitch darkness, can of course have additional benefits in the military context. And if I sound rather confident, it's because, as I hinted earlier, this aircraft is fitted with a practical alternative. It enables the pilot to see as clearly as if he was flying in normal daylight, but in actual fact he could be flying through darkness, through smoke, through heat haze, and even light fog. For example, this is the terrain below us now, and remember, it's pitch dark outside.
Well, try turning it round for you for a bit. Yes, okay. I was going to say, I'm really getting used to the fact that it's the wrong way around. I don't think it makes much odds, but turn it. Okay, it'll go bright for a bit. Into the negative of the negative. I'll fly level for a bit.
How's that?
There we are. Yeah, that looks more like we're used to seeing, doesn't it?
It doesn't seem so.
Oh yes, and then all the hot spots go black, don't they?
Yeah.
Oh, a black sheep, look at that. Oh, goodness.
And that clear view of the ground is shared by an observer, sitting where it's less noisy, further along the body of the aircraft.
That picture is the result of a system called FLIR, Forward-Looking Infra Red. Now, admittedly, the principle of infrared vision isn't new, but the system aboard this Varsity aircraft, a version under development by the Royal Aircraft Establishment at Farnborough, has proved extremely successful. Quite simply, the system, complete in itself and working through a window in the aircraft belly below us here, is converted into a television image on this observer screen in front of me and one in the cockpit forward, so that the pilot can clearly see the ground over which he's flying. There's even a low-light television system installed to make comparisons.
Like this. The difference in definition between the FLIR picture, the upper part of the split screen, and the ordinary television image below of exactly the same piece of coastline is striking. Because the equipment works by detecting very small differences in temperature, rather than reflected light, as in the case of our eyes or the television camera, it can operate in total darkness, and aircrews quickly adapt to infrared pictures.
Even though some objects change their apparent relative temperature at night. Like the pilot, we can now clearly see that power station where we change course.
The south end is on. Power station, I think, being built. And we want to turn onto a heading mic of 090.
And the equipment is not without its military applications, of course, looking beyond the camouflage and detecting a vehicle from its motor heat. Even its recent tracks, where the disturbance of soil creates a different temperature from the surrounding ground. Similarly, it's easy to detect the heat from a ship's funnel. We recorded some pictures earlier on video which clearly show the equipment's potential in picking out strategic targets in poor conditions. An oil tanker clearly visible. And FLIR, you notice, can even pick out the changes in wave profile in the wake of the ship. Now, the FLIR equipment here has already logged countless flying hours, and as it's reaching the end of its operational life, the picture quality is deteriorating. But if we look at our video again, here are some pictures on more recent equipment.
I was flying on the picture actually without looking at the red out at all, and I was chatting away.
So, the program and the equipment is under constant review and assessment. As we've seen, the ability to fly at night is greatly enhanced by FLIR. Even more valuable would be the ability to land at night without the use of any lighting aids. As we reach the end of this night sortie, just watch as the pilot makes his approach for landing to evaluate this next stage.
Outside the cockpit, a confusion of building and streetlights. But for the pilot and the observer beside me, who both had the FLIR image before them, there's no doubt. The runway ahead, clear as daylight.
This is nice, isn't it? Such a beautiful picture. I mean, it's easy to fly on this. Slightly left, coming to the line up. A little bit more left, that's a touch more left, sort of there now. think we're approaching at a slight angle actually, but not too bad. Okay, coming over the threshold.
I can see the difference between concrete and tarmac actually. The concrete area is slightly darker.
That's it.
I could land on that without any trouble.
Impressive, isn't it? It's a program of constant development and assessment, as I say. Not only the high-performance equipment of the Royal Aircraft Establishment, but other systems too. Here they can be evaluated in conditions uniquely designed and adapted by the RAE. The principle is simple. The practical results and implications far-reaching. Forward-looking infrared, FLIR, is at the threshold of production.